All right, let's take a look at these two homework problems. Your first real experience with proofs, with geometry proofs. So we were given that angles 1 and 3 are complementary, and angles 2 and 4 are complementary, and they are referencing these angles that are in this picture over here. All right, and we need to prove that angles 1 and 4 are really congruent or equal to each other. All right, so first things first. Let's take our given information. Let's drop it down here on a line. Let's make it a straighter line. There we go. And we'll say there's our given. Now, I would advise taking that given information if it's something that needs a little bit more doctoring up with. We have a couple vocabulary words, complementary, right? So we need to discuss what does complementary mean to this problem. And so we can go ahead and state that angle 1 and angle 3 we know have to add up to be 90 degrees. And we know that angles 2 and 4 have to add up to be 90 degrees. And how do we know both of those are true? And this is where I'm just going to kind of cluster this together. And we know this is true because of that vocabulary word, complementary. So by definition of complementary or complementary angles, we know that they add up to be 90. Now, at this point, I'm still not going to talk about something else that's going on in this picture. We'll kind of save it because I can keep doing some math with this information that I have. And so since angles 1 and 3 add up to be 90, and 90 is also equivalent to angles 2 and 4, then I could use a particular property that you're going to start seeing a lot more in being the transitive property. Right? The equals 90 is our connector there to really say that angles 1 and 3 added together, well, it's the same amount as if I had added angles 2 and 4, right? Because they both are equal to 90. So there is the transitive property of equality. Now, remember, we're trying to get 1 is congruent to 4, 1 is equal to 4, but we've got these other angles in the way. Angles 3 and 2, always ruining parties. So how do we get rid of them? Well, now this is where we may need to go do some other investigating. What else geometrically in this diagram do we know is true? And hey, there's a particular name that angles 2 and 3 have, and they are vertical angles. And it's something that we've already discussed, right? That vertical angles are always congruent to each other. So we know that angle 2 is equal to angle 3. And again, we called that the vertical angles theorem. And so now here's that connection. Now we're going to kind of take these two pieces of information and we're going to kind of combine them with some substitution. So I'm going to have angle 1 plus, and I'm just going to leave angle 3 the way it is. But this angle 2, what can I substitute it out for? Well, I can substitute out that angle 3 or angle 2 for an angle 3. So this angle 2 is going to turn into an angle 3. And so by the substitution property of equality, we made that swap. Now, could you have swapped out this angle 3 for an angle 2 and then left this angle 2 alone? Yeah, you could have done that as well. It's going to accomplish the same thing in the end. So again, remember, we're trying to get 1 is equal to 4. We've got 1 plus 3 is equal to 3 plus 4. And so now it's just that angle 3 is the same on both sides. But what property, what basic mathematical property could we use to get rid of angle 3 on both sides of the equation? And we could use some subtraction property. So if we subtract angle 3 on the left side, we'll be left with angle 1. If we subtract angle 3 on the right side, we'll be left with angle 4. So using the subtraction property of equality, we now have that angle 1 is equal to angle 4. And to me, I'm good with just saying that's the same as saying that they're congruent to each other. And so there is the end of our proof. Now, a couple other little side notes I want to throw out here. Could you have talked about this vertical angles theorem earlier on in the proof? Could you have talked about it basically as the second step of the proof? And yeah, you could have talked about it then, sure. and then talk about the complementary angle definition, and then start making the substitutions with the transitive properties. Absolutely, you could have done it that way. All right, let's take a look at the second problem here, number 23. So angle AEB is congruent to angle DEC, and that's the two angles that are already marked for us in this picture. What we need to show is that angle AEC, so this angle right here that I'm highlighting in pink, is congruent to angle DEB, which is this angle I'm highlighting in green. So if you kind of notice the pink angle and the green angle, there's some overlap in there, right? Where do they overlap? They overlap at angle BEC. So obviously, if they overlap at that one angle, that angle's the same in both the pink big angle and the green big angle. And so that kind of leaves us with if I can get my tongue straightened out here, that what that leaves us with is the parts that are not overlapped, and that would be this angle AEB and this angle CED. And guess what? They're given to be congruent to each other. So maybe the gears are starting to turn in your head a little bit. We're going to have to kind of pull this all together, okay? So first step, we could almost just write this, right? We could almost write this and then just say given. But now we need to talk about what is so special geometrically in this problem. And it's really that whole, like, if we know we need to talk about this angle AEC, and we know we need to talk about this angle DEB, then it kind of makes me feel like they're wanting me to combine some smaller angles into a bigger angle and some smaller angles into a bigger angle. I'm getting the warm and fuzzy feelings here that they're wanting me to use the angle addition postulate. So that's the direction I'm going to kind of go in for right now. So angle AEB plus angle BEC, that angle that's in the middle, adds up to be big angle AEC. And I'm going to go ahead and knock out at the same time the other angle addition postulate, angle DEC plus angle, and it's that same middle angle, angle BEC, right? These two angles combined all together equal angle DEB. Now, you'll notice AEC, oh, that's not a highlighter. Let's try it again. AEC, we've now talked about it. Angle DEB, we've brought it into the problem. So I'm starting to get some good warm fuzzy math feelings here. And we use the angle addition postulate 2 times. But we're just going to kind of group them together and say, yeah, we did it twice. We're good there. All right? Okay. Now what can I do? Can I combine these two in any way? Can I use, like, I don't know, the transitive property of equality? And I can't yet, because, you know, these things don't match up. These things don't match up. And so that transitive property, it's really close to working, but not quite. So this is where that given piece of information is going to come into play. So what we're going to do, and I'm just going to pick on this second angle addition postulate. So where it says angle DEC, I'm going to swap that out with what we were told the DEC is equivalent to, angle AEB. So angle AEB plus, and then I'm going to keep everything else exactly the same. Angle BEC equals, and then still angle DEB. Okay, so everything else stays the same, except I just made the substitution for that angle DEC. All right, so there is true substitution, property of equality. And now here's where I want to draw your attention to. Notice this new thing and this older thing that we haven't used yet. Notice the left sides of those equations. Angle AEB plus angle BEC. Angle AEB plus angle BEC. They're a match, which now means we can use that good old transitive property to pull together what those two pieces are there on the right side. So now, let me undo all my highlighting. Now I can go ahead and say that angle AEC is equal to angle DEB. And there's just me using the good old transitive property of equality. Again, let me just point it out again. I know that these two things are going to be equal to each other because they are both equal to the same exact things right here. AEB plus BEC and AEB plus BEC, that's my connector for the transitive property. So that tells me I can pull together angle AEC and I can bring that together with angle DEB. And that's what I was asked to prove. So there's the second problem. So again, notice these proofs, they're not very long, but they really make you start to think and put together some puzzle pieces that aren't really easy puzzle pieces to try to fit together. But again, practice with these and just trying them, forcing yourself to try these out and just think about, it's almost like just think of what would Mr. G think next? What would Mr. G think next? Just think about that and kind of in the back of your mind as you're trying to start to do these problems. All right? So hopefully you did at least some of that on your own. And then hopefully I helped kind of pull it together for you there in the end.